students, let's come back and do the 15th question of your NCERT. So we've already read the question in the earlier video. Let's see. So here, first important thing is, I need to, we have a lot of things, right? So whenever such question is given to you, try to write or separate the equations one after the other. Let me take the page. I need to calculate the enthalpy change for the process. So this enthalpy change, let's do step by step. So for this reaction, when I have to write the solution, first important thing, what should I find out? Right? So here they said calculate the enthalpy change, delta H I need to find. Let's write step by step. First of all, first reaction given. What do they give me? They've given me CCl4 gas or giving me carbon plus chlorine. This is what is the question, isn't it? Right. So let's know that. First of all, according to this is given CCl4. Fine. So this is giving CCl4, okay, and calculate the bond enthalpy of CCl and CCl4 gas. Okay, then that's why you need to start from the liquid state, then converting into gas. For this CCl4 gaseous state, how much is delta H vaporization? Because the conversion of liquid to gaseous state is nothing but delta H not vaporization, isn't it? How much is this? This is equal to 30.5 kilojoules per mole. This is also over. Let us name this as reaction 1. Now let us go to the next reaction. Next reaction is what? Carbon. So they have given us after vaporization, this I've used. Then they said the atomization also is given to me. Yes. So here formation, this atomization concept, because where the H0 enthalpy of atomization of chlorine is given. So what is that? This is basically second reaction. Carbon solid combining with chlorine gaseous giving me CCl4. This is liquid. So how many chlorines? 2. Now how much is this delta H formation of CCl4? This is nothing but minus delta H formation of H0 is nothing but minus 135.5 kilojoules per mole. This is also over. Now next one, enthalpy of atomization, that is carbon solid getting converted to gaseous state. In the third step, carbon solid getting converted to carbon gaseous. Here delta A atomization is equal to 715.0 kilojoules per mole. This is also over. Now in the fourth reaction, here what else did they give us? They've given us delta H atomization Cl2. This is what they've given. Let us note that atomization is nothing but breaking down of the molecule into the individual atom. So 2Cl gaseous, because 2 chlorines. How much is this? Delta A H0. How much is this given to us? It is nothing but 242. Okay, 242 kilojoules per mole. This is also over. Now I've noted everything. Now what we are going to do? First we are going to multiply equation 4 by equation 2. Why? Because we need to find the standard, means the enthalpy change, isn't it? So that's CCl4. That's according to the question. So what first I'm going to do? Multiply equation 4 by 2. Okay, so I'm relating. Let us see. So now I'm going to multiply this. Why? When I multiply this equation 4 by 2, I automatically will get to that final thing. Just see why am I doing this? When I multiply equation 4 Cl2, which is in gaseous state, I'm going to get this 2Cl is already there. I copied. Now I'm multiplying with 2. So this becomes 2Cl2, which is in gaseous state. Giving me 2 to the 4 Cls gaseous state. Yes, because Cls are 4, I'm almost coming a bit closer to that thing which we get. So here what will happen when I multiply? You should multiply with this also. So this becomes delta H. Atomization thing of H0. When I multiply with 2, we get this as 484. 2 to the 4. Okay, this is 484 kilojoules per mole. Okay, this is also over. Now what am I going to do? This multiplication is over. Now I am going to add equations 3 and equations 5. Okay, let us name this as equation 5. This is 5. So now let us write. You are going to add equation 3 and equation Fine. What do I get when I add both? So let's write that step. Adding equation 5 and equation 2. So when I add both of them, what do I get? I get carbon. It is solid. Let's see this. What do I get? Yeah, I get carbon which is in solid state plus 2 chlorines gaseous state, which gives me carbon gaseous state plus chlorine, 4 chlorines gaseous state. Delta H for this is 1199 kilojoules per mole. This is also over. Now what am I going to do? I'm going to reverse equations 1 and 2. Okay, both the equations I'm going to reverse. So what will happen when I reverse the equations? Let's try that. Adding is over. Now I'm reversing it. Reversing equations 1 and equation 2. This is underlined. Now then, how do I name this? Let me name this as equation 6. Now when I'm reversing, let me write that as equation 7. When I reverse, I get carbon 4 gaseous state gives me CCl4 liquid state. Here delta H for this is minus 30.5 kilojoules per mole. Yes, let's do now write the 8th equation. Yes. So I'm reversing equation 1 and equation 2. So when I reverse equation 2, I get CCl4 liquid gives carbon, this is again solid, plus 2Cl2 gaseous. So delta H for this is plus 135.5 kilojoules per mole. That is what is given, isn't it? See here. When this is minus, when it is reversed, this becomes plus. Over. So equation. Now what am I going to do? I'm going to add equation 6 and equation, I'm going to add 3. I should add 3 because CCl4 I need, isn't it? I am going to add equation 6, I'm going to add equation 7, I'm going to add equation 8. All 3 I'm going to add. So add equation 6, 7, 8. So what do I get? If I add CCl4, okay, let's see what would get cancelled. This carbon, okay, this carbon and this carbon gets cancelled. This 2Cl2, this 2Cl2 gets cancelled. Yes, what is left now? We are left with this, let's see, anything else will get cancelled. This CCl4 liquid gets cancelled. Now I'm left with only this one. So this becomes, let us write the final equation. CCl4 gaseous state gives me here what is left? Carbon, this is also gaseous state, plus 4Cl gaseous state. Now see here, carbon 1, CCl4, 4. This is gaseous state. So now what is delta H here? Delta H becomes 1304 kilojoules per mole. Okay, right? So because we are going to add everything, add this one, this one, this one, you get 1304 kilojoules per mole. Fine, let me take one more paper. I need one more. So still, what did they give? The bond enthalpy. They were asked what is this said? Calculate the bond enthalpy. This part is over. Enthalpy change I got. Now I should find calculate bond enthalpy. So bond enthalpy when I take, right? So let's see. Calculate bond enthalpy of CCl4. So how much is this? How much did I get? I've got 1304. How many moles is it of bond enthalpy of carbon in this one? So this is 1304 divided by 4, which comes to 326 kilojoules per mole. Why did I take 4 here? What did they ask me? They've asked me calculate the bond enthalpy of CCl in CCl4. Okay, how many are there? That one. Bond enthalpy of CCl. So CCl are 4 in this. So I divided by 4. So why? Because there are 4 bonds, isn't it? Isn't it in CCl4? This is like Cl. So 1, 2, 3, 4. So I divided with that. So the answer is 326 kilojoules per mole. So I've got this 1304 by adding, multiplying, dividing everything. So this is the final answer. So hope students the concept is clear. So first of all, what did I do? I have read numerical, then I've written the given reactions, then I've written multiply factor, then I added it, then I've reversed it, finally got the reaction, and for finding the bond enthalpy I have divided by 4 because there are 4 bonds. Right, now let us take out this 615. Now let us do 616. Right, 16. So here in the 16th numerical, very simple numerical, what do they ask us? For an isolated system, delta U is equal to 0. What will be delta S? That is what they've given us. So isolated system. What is isolated system? Let's write the conditions first. So here I've done one video in the earlier things, starting when I did isolated system, adiabatic system, isothermal. So for isolated system, always remember what are the conditions. So they've already given us. Let us note that and further discuss. U is 0. Right. So, and first important thing, for isolated system, the internal energy is 0. And for a spontaneous process, right? So now if you want this reaction to happen, or this thing, if you should have a spontaneous process, total enthalpy change should be positive. That you should remember. Once again, if a reaction should be spontaneous, we call a reaction to be spontaneous when total energy, or sorry, total entropy change, right? So that entropy change is nothing but delta S should be positive, right? Right. So now, what should we say? They asked what is delta S. So we already know one reaction which we have studied. What is that? Delta S is equal to Q reversible by T. This is what we have studied, isn't it? Fine. So now if you have two gases A and B, right, they are kept in a movable partition. There's a movable partition which is moving. So when the partition moves from front and back, what will happen? They begin to diffuse to each other, isn't it? And the system, what happens? The system becomes more entropy. I mean, the entropy disorderness starts increasing when you're placing that thing, movable piston. So now what happened when they're moving? Diffusion increases, delta S will become more than 0 and delta U also will be more than 0, isn't it? For such conditions, right? So now remember that one. Now here when I explain, this is one more formula which we have studied. Entropy change is equal to Q reversible by T, which is equal to delta H by T. Isn't it? Fine. So what is delta H? Delta H is nothing but delta U plus P delta V. This T is like that only. Right. So now we said isolated system. In isolated system, delta U is 0. So what will happen? Delta S is equal to P delta V by T. Right? Fine. So T delta S, that is nothing but T delta S, isn't it? So when I multiply this, cross multiply this here, what will it become? It will become T delta S is equal to P delta V. That means, what does this say? This delta S value is greater than 0. Isn't it? That is what it says, change in enthalpy. So they said delta U is 0, then delta S will be greater than 0. So this is your answer which you should remember. Right. So now let us come back and see question number 6.17. So here in this question, what did they give us? They said for a reaction at 298 Kelvin, okay, 2A plus B gives C. This is one reaction which is given, right? Delta H value is given, delta S value, enthalpy change is given, entropy change is given. What should I find out? At what temperature will the reaction become spontaneous, considering delta H and delta S to be constant over the temperature range? Yes, right. So first of all, I should find at what temperature, right? I need to find the temperature at which delta H value as well as delta S value is to be constant. Let's write. So what data is given? Let's note. First of all, how much is delta H given? Delta H is 400 kilojoules per mole. This is what is given, right? Then they've given delta S value. Let's copy that value also. Delta S value is how much? It is nothing but 0.2 kilojoules Kelvin inverse mole inverse, right? This is given. Fine. So here what temperature I should find? So what is the formula which is relating all this? It's nothing but Gibbs free energy change, isn't it? So according to Gibbs free energy change, that is delta G is equal to delta H minus T delta S. Yes. So what is delta G here? We said the reaction, see here, we said for a reaction to be spontaneous, delta G should be lesser than or equal to 0. Because this is spontaneous reaction. That is the condition, isn't it? So the reaction becomes spontaneous. So this is 0. We very well know. Delta G for a spontaneous reaction. If I have to see, delta G is nothing but it is lesser than or equal to 0. So this becomes 0 now. How much is delta H given to us? It is given 400. Okay, 400 kilojoules per mole. Kilojoules per mole. Minus T into how much is delta S value given? It is nothing but 0.2 kilojoules per mole. Kilojoules, Kelvin inverse, mole inverse. Now I need to find this temperature because they were asked at what temperature will it become spontaneous. Take out this temperature out. What do I get? 400 kilojoules per mole divided by 0.2 kilojoule Kelvin inverse mole inverse. So how much do I get? I get an answer of when I divide 0.2, 400 by 0.2 gives me 2000. So kilo and kilo, this gets cancelled. Mole gets cancelled. Joule gets cancelled. I am left with 2000 Kelvin temperature. So now what happened here? Therefore above 2000 Kelvin, the reaction will become spontaneous. So when temperature is above, they asked me at what temperature will the reaction become spontaneous. So you should write reaction becomes spontaneous above 2000 Kelvin. That's it. Right? This is how we are going to do. Right. Let's come back and see the 18th question. Right, welcome students to one more session of your NCERT Numericals. Let's do the 18th question of your chemical thermodynamics. I've been doing almost 17 numericals in this. Let's read this. What do they give us? For the reaction 2Cl gas gives me Cl2 gas. What are the signs of delta H and delta S? Right. So in this particular reaction, what is this? A molecule of chlorine. Okay, this chlorine is formed from where? It is formed from two gaseous atoms. This is your gaseous, this is the gaseous atom, this is the chlorine molecule, right? So two are formed or a chlorine molecule is formed from two gaseous atoms, isn't it? Right. Now when the energy released here, they said what are the signs? So and the energy whatever is released in the formation of this bond, obviously it is formed, isn't it? Energy is obviously released because it is formed from that. So when energy is released, what are we going to do? Two chlorine atoms, from there your gaseous molecule is formed. The coming closer to each other. So obviously when you're converting or when you're forming a molecule from gaseous atom, delta H value will become negative. Now I should speak about delta S value. So what will happen in such reaction? Delta is nothing but entropy, isn't it? The entropy, the randomness also decreases. Why? Because 2 moles of chlorine, this has more randomness than 1 mole of chlorine, because 2 means they're colliding, they're moving, means that collision factor always there. When they're colliding, automatically the randomness or the disorderness increases. Correct? So what should I say? Delta S value should also be less. Why? What did we say? Let us say delta S also will become negative. What is the reason? More randomness is observed. More randomness is observed in 2 mole atoms of chlorine. Correct? Right. This is how you're going to explain. So remember, this has more randomness compared to this. Nothing but S entropy is negative for this. Let's see the 19th question. Right. So here what do they give us? They've given us for the reaction 2A plus B, okay, gives us 2D. Then they've given us, okay, it gives me 2D. This is what internal energy, this is standard, not. It's how much? Minus 10.5 kilojoules. And this is also not standard, and entropy change is minus 44.1 joule Kelvin inverse. Calculate G naught. Okay, I need to calculate G naught. This is G naught. It has become this. G naught for the reaction, and predict whether the reaction occurs spontaneously or not. Right. So here, what should I find out? I need to basically find out standard Gibbs free energy change. So here, what important thing is, as soon as such reactions are given, your concentration should go here. Why? Because these are gaseous reactants and gaseous products. For gaseous reactant and gaseous products, the formula which you should, or which you're going to use always is, it is nothing but delta H naught is equal to delta U naught plus delta N GRT. This is the formula which we are going to use for gaseous reactants and products. Remember this. Based on that, we'll start. Let us copy the reaction. It is 2A. Right now, what is delta Ng? That also we'll write. Like delta Ng is nothing but number of moles of the product minus number of moles of the reactant. Remember this. I've already discussed this. I've repeated here. Now copy the reaction. Delta A. 2A plus B gives me 2D gaseous. Right. Now let us calculate delta Ng. What is delta Ng? Number of moles of the products minus number of moles of the reactants. How many products? What is the number of moles of the products? 2 minus 3, because 2 plus 1, 3. So it is 2 minus 3, it is minus 1. Okay. Now what should I require? I require R. R value is how much? Gas constant is nothing but, it is 8.314 into 10 raised to the power minus 3 kilojoule per Kelvin. Kilojoule per Kelvin mole. Okay, Kelvin mole. Okay, I don't have place here. What is T value? T value is nothing but 298 Kelvin. So I have all the values now. Start substituting in this. Delta H naught, I should find out. What is delta U naught? They have given me as minus 10.5. Let's substitute. So delta H naught is equal to minus 10.5 U naught value kilojoule plus delta Ng is nothing but minus 1 into 8.314 into 10 raised to the power minus 3 into 298 Kelvin. When I solve this whole thing, how much do I get? Delta H naught, I get minus 10.5. I'm solving the one which is inside the bracket. Get equal to plus minus 2.477 kilojoule per mole. When I solve this. Further, if I solve this, plus into minus is minus. So minus 10.5 this one. When I solve, I get an answer of minus 12.977 kilojoule per mole. Fine. I should still not done. I need to find delta G naught S. G naught, that is Gibbs free energy change. So what is the formula which is relating delta G and delta H naught? Let's see. We very well know delta standard Gibbs free energy is equal to delta H naught minus T delta S naught. Because it's standard. Now what is delta G naught? Like how to find out? Because delta H naught I already got from here. It is minus 12.977. Let's write that. Delta G naught is equal to delta H naught is minus 12.977 minus of T is 298 Kelvin into how much is S naught given to us? Minus 44.1. So let's write that. It is nothing but minus 44.1 into 10 raised to the power minus 3. So when I solve the one which is inside the bracket, get delta G naught is equal to minus 12.977 plus, because minus into minus becomes plus 13.14 kilojoule per mole. Now when I further solve this delta G naught value, I get an answer of plus 0.165 kilojoule per mole. Right. Now what did I get? I got delta G naught value is positive. Remember, if delta G naught value is positive, that means the reaction will not occur spontaneously. Only when delta G naught value is negative, we will get spontaneous reaction. So we will write, since delta G naught is positive, the reaction will not occur spontaneously. Remember that. This is your question, right? So we have solved question number 19. Let's come back and solve question number 20.